The universe speaks in many languages. One of its most elegant is the language of vectors. Vectors are more than just numbers. They are guides that encapsulate both magnitude and direction. Imagine a force pushing an object. To fully grasp this force, we need to know how strong it is. The magnitude is, and where it's pushing, the direction. This is where vectors shine. In the realm of physics, vectors are indispensable. They paint a complete picture of motion, force, and many other phenomena. From the trajectory of a baseball to the flow of air around an airplane wing, vectors are the invisible architects of our physical world. In the world of physics, we encounter two fundamental types of quantities: scalars and vectors. Scalars are content with just magnitude. Think of temperature, mass, or time. These quantities are fully described by a single number and a unit. 70 degrees Fahrenheit, 10 kilograms, 30 seconds. These are all examples of scalars. Vectors, on the other hand, yearn for more. They demand both magnitude and direction to be fully understood. Velocity, for example, is a vector. It tells us not only how fast something is moving, the magnitude, but also in what direction. Imagine two cars traveling at 60 miles per hour. Without knowing their directions, we have an incomplete picture. Are they moving towards each other, away from each other, or in completely different directions? Velocity, as a vector, provides this crucial directional information. Vectors, like dancers in a cosmic ballet, interact and combine through addition and subtraction. Imagine two forces acting on an object. To find the net force, we add the vectors representing these forces. This is done by placing the tail of one vector at the head of the other, maintaining their original magnitudes and directions. The vector drawn from the tail of the first vector to the head of the second represents the sum, or resultant vector. Vector subtraction follows a similar principle. To subtract one vector from another, we simply add the negative of the second vector to the first. The negative of a vector has the same magnitude but points in the opposite direction. These vector operations are essential for understanding how multiple forces or velocities combine to influence the motion of objects in our world. Section 4. Vectors in action: real-world applications. Vectors are not confined to the pages of textbooks. They permeate our everyday lives, often working behind the scenes. Consider the simple act of crossing a river. You aim your boat at an angle upstream to counteract the river's current, which would otherwise carry you downstream. This scenario involves vector addition. Your boat's velocity plus the river's velocity result in your actual velocity across the river. In the realm of engineering, vectors are paramount. Architects use vectors to design stable structures, ensuring that forces are distributed effectively to withstand gravity and external loads. Engineers designing airplanes rely heavily on vectors to calculate lift, drag, and thrust, ensuring that the aircraft can take flight and maneuver safely. Section 5. Vectors, the unsung heroes of our physical world. Vectors, though often unseen, are the unsung heroes of our physical world. They govern the motion of planets and stars, dictate the flow of fluids, and underpin the very fabric of space and time. Without vectors, our understanding of the universe would be incomplete, like a map missing crucial landmarks. By embracing the language of vectors, we gain a deeper appreciation for the intricate dance of forces and motion that shapes our physical reality. From the smallest particles to the largest celestial bodies, vectors provide the framework for understanding the fundamental laws that govern our universe. Section 6. Beyond the basics. A glimpse into advanced vector concepts. Our exploration of vectors has just scratched the surface. As we delve deeper into the world of physics and mathematics, we encounter more sophisticated vector concepts, such as dot products, cross products, and vector calculus. These advanced tools allow us to tackle complex problems involving rotating objects, electromagnetic fields, and the curvature of space-time. The journey into the world of vectors is a journey without end, filled with endless possibilities for discovery and understanding. As we continue to explore the universe around us, vectors will remain our steadfast guides, illuminating the hidden patterns and principles that govern the cosmos.